Hi, I'm Victoria, a member of Team Heat Press. This semester, our team built an automatic heat press, a machine that applies heat and pressure to imprint a design on fabric. When first designing our heat press, we had a lot of questions about the pressure, heat, force, time, materials, area needed to build a working heat press. And thus, we had a bunch of different designs before we reached our final one. In our super awesome final design, an airbag made out of duct tape inflates to apply the pressure needed for the heat press. The majority of the base and structure is built from wood and our square tubing. We also utilize a wooden press plate to apply a more rigid pressure to the fabric and 14 by 14 inch heating pad.
Done, came time to build the heat press. The design of the heat press requires a structure that's capable of withstanding forces many times stronger than can be handled with things we were more familiar with, like 3D printing. So we needed wood 2x4s, planks, sheet metal, insulation, brackets, metal members, and a number of bolts and nuts, both long and short. So we considered using 80/20 for the metal frame, but because of the price and because of the fact that in comparison to a donation of steel tubing that was free, we couldn't fit it in our budget. So we had to cut these members to size. And after many trips to the hardware store and this donation, we were ready to build. Over the course of several days, our team went from approximately zero knowledge of power tools to sawing, grinding, cutting our way to a working prototype. We had to cut our metal into 8 members, cut our sheet metal to size for the press, and somehow form the 2x4 into a square. Also saw the plank into 3 smaller, more carefully shaped planks. We finally put it all together, and we were ready to integrate the airbag and the control electronics.
Hi, I'm Ben, and I was on the electrical team. The core of our electrical system is the Adafruit Clue, which is a Bluetooth-capable microcontroller. We chose the Clue because most of the team already had one from our Makeathon event. This allowed us to test and develop the control system remotely. The Clue controls our 2 main electrical components, the heating element and the solenoid-controlled air valve. To control the heating element, which is similar to what you find in a 3D printer, we use data from a calibrated thermistor to sense the current temperature. Based on this reading, we would apply or cut power to the heat bed using a relay that was wired in line with the power cable. We also needed to independently control the airflow to the airbag for 2 reasons. We don't want the airbag to pressurize until the heating element has fully heated, and we also want to automatically release pressure when the timer is finished. Using a similar relay control structure as the heating element, we're able to toggle the position of the solenoid-controlled air valve to either connect the airbag to the air compressor, which would inflate it to the desired PSI, or to vent the airbag and redirect the air compressor, allowing the bag to deflate. The default state when no power is supplied to the relays turns off the heating element and vents the airbag, so if there are any mechanical or electrical failures, we don't end up damaging the press or the operator.
Hi, my name is Lauren, and I'll be talking about the software side of our heat press project. For the software side of our project, we created a basic software state machine model to represent the different actions needed to control the heat press through the Clue microcontroller that Ben mentioned. This includes states of idle, preheat, arm, and heat press. Idle represents the resting state of our machine. This is before the heating pad has been heated up or the airbag inflated. When the user presses the start button for the first time, the machine enters the preheating state, in which we turn on the heating element. Once the desired temperature has been reached, we enter the arm state. When the start button is then pressed again, we enter the heat press state, in which the airbag is inflated and the heat pressing process begins. Using the Bluetooth capabilities of the Clue, we were able to modify the existing Bluetooth application and use it to control the heat press remotely, increasing the safety of our project.
Hey guys, I'm going to go ahead and walk you through the assembly that I did today. It was majority drilling. I did that all day today. As you can see, I had to drill through a lot of steel. And then we had to make sure that it lined up perfectly and the nails were vertical the entire time. Then we got to the fun stuff. I made a cute logo and we're printing it out in the printer on transfer paper. Next we moved to the Clue. This is supposed to control both the temperature and the pressure inlet and outlet. Right now we have too low of a pressure for the pressure relay to even work, so I will be manually doing that for showcase and hopefully we can kind of debug it later when everyone's back together in LA, but this is it preheating, and then once it preheats, I'll go ahead and hit start, and theoretically the pressure should start working. Next, I'm just putting the transfer paper and the t-shirt into the heat press, and then I'll go ahead and pressurize the bag and print it out. I will be manually controlling the pressure in the corner over there. Don't worry, I'm sitting far enough away to avoid any shrapnel, and I'm having my brother record this. We'll go ahead and watch it pressurize, and then afterwards I'll show you guys the final product. Then I pulled out the heating pad and the design, and you guys will have to stay tuned for the live demo to see the final product.